Hello everyone, welcome back to the episode 2. In our last video we wrote a couple of lines of code to download and visualize the entire street network of Manhattan, as you can see on your screen. But we want to see what's behind these straight lines or dots. So today we're gonna do something and see what's the difference between the abstract graphs or spatial geometries. Right, so we are going to pop the hood actually, and we're going to ask or answer the questions that how is the spatial data actually stored. So to do spatial network analysis, we have to understand the difference between abstract graph data and physical spatial geometries. Right now, the network is stored as a network X graph object, which is okay for solving the routing problems, but it is actually different when you look at the data. So we're going to convert this graph into GeoPanda's data frame, which is called GeoData frame. So think of GeoData frame as a Excel spreadsheet that understands geography. So we are going to use again the OSMNX functions, and we'll split our network into two distinct tables, like one for our nodes that connects those edges, and the other one will store the edges. So you don't need to download import the libraries because we already have done it here. So we'll just continue writing our code. So we want to convert the graph that we had into GeoPanda's GeoData frame. Let's just say, just for our reference, converting graph to GeoData frame, just for our concerns. Okay, so we want to put our data into nodes and edges. That's what we call edges are the streets and nodes are the intersections. Nodes and edges equals ox dot graph to GDFS of G. G is the graph. This is where we stored the graph here, which is our street network. Okay, let's run it. Okay, it says OX is not defined. Alrighty. I'm gonna run this again. Import the OX. Okay. It happens sometime when you go offline and you have to run this again. There you go. Okay, let's print it and see if it works. Right. Let's say we have how many nodes. Let's say length of nodes. Oops. Intersections. Nodes are intersections. And edges. That will be our streets. Street segments. Where in Manhattan. Okay, this will tell us how many nodes or intersections or streets we have. So we have 4,000, almost 4,000 nodes and 9,000 streets. Okay, so let's inspect the data tables. When we look at the first few rows of our nodes table, we'll see a list of intersection coordinates, and then each point has exact latitude and longitude. So Python knows precisely where this intersection sits on the earth. So we'll just see nodes dot head. It will show us first few entries, or first 5. So here you can see all the nodes and their longitude and latitude. So let's look at the edges table. This is where you see the lines. Every street segment that has data attached to it, we can view it, view the street length, even the speed limits, and we'll also see geometry column, but instead of points, these are line strings, that actual physical path the road takes. So let's see the edges dot head. There we go. So this is all we have: lanes, name, highway, max speed, and all the details for this. So to prove that these are now separate layers, let's visualize just the nodes versus the edges. And here we'll see Manhattan visualized just as an intersection point, and here we'll try to visualize the streets and then see it together as a spatial network. So let's start the visualization. Equals node dot, we're gonna plot them in short. So let's say the figure size, fig size, let's just keep it to 8 by 8. All will be easy. And then we have to set the marker size, which is the node size. Marker size, let's just not make it too big. 0.5 is fine. You can choose any color. Let's say blue. Alrighty. Oops, sorry. Yeah, you can see that, but I wanted to do something else. Let me do it here. AX nodes equal, I wanted to set the title and everything else so that it looks professional. Nodes dot set title. Manhattan intersections, which is nodes only. And we can set up our font size here, like how big we want our title to be. Oops. Font size 15. So since I'm doing it like line by line, so I'll run it line by line. See, okay, now we have the title here. Oops, okay. Okay, so I just wanted to remove those axes. Now the next part is to plot the edges. We're gonna plot the edge, ax under edges equals dot plot. Let's just keep the figure size same. Made same mistake. Fig size 8 line. Since we are plotting the edges, so it should be line width before we did the marker size. Since there are so many intersections, that's why it looks like lines. So I'm just going to keep it to 0.5. Color. Let's say green. Okay. And I'm going to copy this title code and this access. Just paste it here. So instead of intersection, we'll put streets here, and here will be edges. Okay. Right, made a mistake. Fig size should be here equal. Okay. There we go. We have now the street network. Oh, sorry. We used nodes, should be edges here. Edges, also edges. Making a lot of mistakes. There we go. So this is the street network. So now that we know exactly how street lengths, speed, and coordinates are stored, we are ready to actually use them. And in the next episode, episode 3, we are going to calculate our very first street path route from one point, like let's say point A to point B. So in the next episode, we'll do that. We'll try to calculate shortest path from point A to point B. So stay tuned. We'll see you in the next episode.